This video is going to talk about z-scores and how we use them, or how we can actually convert raw scores into z-scores. I'll go into what is a raw score and stuff like that. All right, so just very quick definitions for z-scores. Okay, it's basically just, it's trying to tell you how far a data point is, either, of course, either above or below. That makes a difference. And then it's just comparing it to the mean, when you think of it in standard deviation. So it's pretty much just bringing like everything so far, mean, standard deviations, and it's bringing it together into one score. Technically, a z-score is really just it's just a number, but this number tells you way more information than basically like any of these right here. Okay. And then the number that the z-score is always going to be in relation to the mean. It's always going to give you basically information about where the mean is, and how far away you are from the mean. So let's go ahead and let's give you an example of, like, why we basically use z-scores. So just imagine that I tell you, somebody named Leah, they got a 75. So the score is a 75. And all I can tell you is just that, right? The score is 75. I don't tell you anything else. So then what do you know? Like, is it a 75 out of 100? Is it 75 out of 200? Like, we just don't know. There's no extra information, right? Is that 75 good? Is it bad? Is it average? We just have no idea. But now, if I were to tell you instead, the z-score is a 1.75, now this is actually going to give us a lot more information, because it's always in relation to the average. So it's basically, this 1.75 is basically like compared to the average. So right now, maybe you don't really see it, because we haven't really talked about it at all. But if I tell you, a z-score is 1.75, then you will automatically know, then it's above the average, and it's you can go ahead and we can figure out what percentage, like how many people did Leah beat, like percentage wise. Like, did she, with this 1.75, did she beat 55%, or did she score above 55%, or like, or 75%? We can easily calculate it. And we don't need to, like, we don't know the average, we don't need to know the average or anything like that, if we just have the z-score. So it basically just gives you a lot more information than if I were just to tell you, hey, somebody scored 75, as opposed to me saying, hey, this z-score is 1.75, tell me more information about it. Okay, so right now it's just pretty vague, right? We're going to go ahead and talk about how to calculate z-scores in this video. I'm going to go ahead and we're going to analyze it a little bit in like 2 examples, but for right now it's just how to get a z-score. Okay, really quickly, z-scores can be both positive or negative. It's very straightforward. It's sort of just kind of falls into the normal distribution a little bit, or in the middle is, the average. And then if the z-score is a positive number, that means it's above the average. If it's a negative number, that means it's below the average, okay, or the mean. Those two words are interchangeable. So for instance, if we see this here, right, did Terry do well on the test? Well, the z-score is a negative number, so that's one thing that you should sort of already like focus on. If the average is here, we know the negative numbers are going to be on this side. So just based off of the fact, if you think of this as a number line, which you should, then that means obviously Terry scored lower, right? Terry scored lower than the average. And then Leah obviously scored higher. And then, if I give you what the standard deviation is, you can easily calculate like where he lands, and if I give you what the mean and stuff. But for right now, that's how you would just compare a positive z-score and a negative z-score. Okay, so let's go ahead and very quickly, I need you to understand this important concept. Z-scores tell us in relation to the average. Okay, that's something you need to understand. A z-score is basically telling you, are you above or are you below the average, and then like how many standard deviations away. Okay, so this very quick question: can a z-score ever be 0? Think about the definition. Think about what I just said. Pause the video and jot down your answer. Okay, it's okay to be wrong. Like, if you're wrong, then that's it. Nothing happens, right? You're wrong. You can try to figure out why you're wrong, try to understand it, and then keep going. So can a z-score ever be 0? Well, if you're talking about, comparing it to the average, where you could be above, that's positive, you could be below, that's negative. Well, what happens if you're like right on top of the average? What if your score is perfectly the average score, right? You fall exactly where the mean is. Well, what that means is you aren't you aren't away from the mean at all. You lie right on top of it. So that means that your z-score will become 0, because the z-score always, basically, it always tells us how far away from the mean, like, my score is, depending on the standard deviations. So if my score is exactly the average, then that means I'm nothing away from the average, and so then it'll be 0. So a z-score can be 0. Okay, that's something that some questions will try to trick you in it and whatnot. Okay, so let's go ahead very quickly. This is a really nice, clean summary of what I've been talking about right now. Right, so if a z-score is 0, it's on the mean. It basically is the mean, if you want to think about it. If it's positive, it's above. If it's negative, it's below. Okay, and then these two down here are just trying to tell you, how it relates to the standard deviations, because it's all about, standard deviations, and then comparing it to the mean. So let me go ahead and this here equation. I know that some of you are probably going to look at it and be confused, but it's okay. We'll take it one letter at a time. Okay. The Z, obviously, stands for z-score. And now let's go ahead with the first letter. That X right there. If you notice, it's just the X. It doesn't have the little bar on top. We call this one to be the raw score, or basically this is what you got, or what the person got. If we're talking about a test, that's their score. If we're talking about a race, that's their time, right? So X is what the person got. Okay. The next one is going to be the X with the bar on top. And we know from the normal distribution curve, this is just going to be the mean, or you can say the average. Okay, so whichever one you want to, but it's just the average. And then you notice there in the middle, it has a little minus sign, right? That means you would just get these two numbers and you would subtract them. And then we would go ahead and divide by SD, which, I mean, we can sort of figure that out. SD stands for standard deviation. Okay. Since the standard deviation is the denominator, right? Since the standard deviation is in the denominator of the fraction, what this means is that the standard deviation cannot be 0. Okay. It can't be 0 because then we get into the equation, right, where it's an error, or it's, I forget the actual word for it, but whatever. And then I know right now some of you guys are gonna have a hard time understanding why, but this is super important. Hundredths place is 2 decimal places after, so you always need 2 places after the decimal. Okay, I think for the first couple of examples we don't really get decimals. I'm not even sure, but my whole point is just that you always need to have 2 decimal places. Okay, we can use the third one either to make this number go up or stay or whatever, but we always need 2. When you get to the more difficult problems, you will see why. Okay, let's finally get an example on how this equation works. I promise you that it's not that hard. So let's see, I'll put Leah in red. Okay, so Leah's test score is a 75. I'm already telling you that the z-score is 1.75. Okay, so that right there, I'm basically giving you the answer already. All I'm going to give you is more information so that you can see where this 1.75 came from, not sort of like I just randomly made it up. So let's do the work for Leah. All right, so the equation is this one right here, and it is never going to change. It's always going to be that one for this class. I'm not entirely sure if in a higher stats class it'll get more complicated, but for right now, let's just use that one. So z-score is equal to X is going to be her score, so 75, minus X bar. That's what we call that one. X bar, if you remember, that's the mean. So we go over here in the more information. The mean score was 68. So we'll do minus 68 divided by the standard deviation, which is just 4. So it's really just plugging into this equation. It's not that bad. Notice how you can get a negative number though, right? If this number is bigger than this number, then that's how you get a negative number. All right, so let's go ahead with actually, subtracting and whatnot. So 75 minus 68, I believe it's 7. Let me just check that. Yeah. So it's 7 divided by 4, and that right there, plug it into your calculator, it's going to be 1.75. Okay. It's So that's Leah's z-score. Her z-score is 1.75. So you obviously need the average, the score, the raw score, and the standard deviation to figure the z-scores out. So let's go ahead with Terry. And this is where you have to be careful, okay? Some of you guys are gonna already like want to create like little shortcuts, like, oh, the biggest number, blah blah blah. No, just use the equation, right? Just have this somewhere written all the time. All right, so let's see. Terry's score is 62. The average, subtracting the average, which is 68, and then divided by standard deviation is 4. So then we go ahead, 62 minus 68, that's -6. And then there you go. You see, like, this is how you get a negative z-score, right? If the average is higher than what the person got. So it'd be -6 divided by 4. And then if I go ahead and I put that into a calculator, it's going to be equal to 1.50. Now, I know some of you guys are going to say, well, can I just write -1.5? Force yourself to always give me 2 digits after, okay? If there's nothing else, then go ahead and, tack on a 0 there. But I need you to start forcing yourself. It's going to be really important once we start looking at the table, the z-score table. And if that confuses you, that's fine, okay? We're going to get there eventually. So there you go. That's how you do it. It's not that hard, right? A couple more examples, and then you'll be good with this. So pause the video, see if you can do this one by yourself. It's not that bad. Go ahead. Okay, so for this problem, you just got to read it and stay organized, okay? So in January 2015, the mean, okay, so we're talking about average there, the mean total snowfall for a group of cities was 30 inches. So I'm going to go ahead and do that. So the mean, we know it's going to be 30 inches. Standard deviation of 6.5. So there you go, 6.5. Find the z-score. All right, cool. So that's what I'm looking for. Z-score is equal to, and then I know it's a fraction, minus sign. There you go. For a city that had a snowfall total of 32 inches. So this 32 inches basically is the raw score. Oops, sorry, that should not go there. It's like the raw data that you're basically trying to compare to the average and stuff like that. So then all we have to do is plug it in. So the equation says, raw score first is going to be 32. Or raw data, if you want to think of it like that. It's up to you. 32 minus 30 divided by standard deviation, which is 6.5. That's going to be 2 divided by 6.5. And then that's where basically I have to now use a calculator. And it's totally fine. Use a calculator. So after I do 2 divided by 6.5, I get 0. What is that? 30769. So I'm just putting a bunch of numbers, and then we'll talk about, now how to actually get the answer. So 0. And then remember, round to the nearest hundredths. So I need 2 decimal places. So basically, to figure out what I'm going to do with the 0, I just need to look at the next number. Since it's a 7, that means the 0 is going to go up to the 1. So then, sorry, that's super bad. So then that'll be my answer for the z-score. So it'll be 0.31. The fact that it's such a small number basically means like this city's z-score for the snowfall is super close to the average, right? It's like basically there. It's 0.31 standard deviations away. I mean, think about that's saying it's really, really small. And then if we compare the two numbers, well, yeah, that makes sense, right? The average was 30 and they got 32. It's positive because the raw score or whatever is higher than the average, okay? So it's just little things like that. So let's go ahead, pause the video, see if you can do this one. Josh scored 82. Okay, so that's Josh's score. He scored 82 in a recent tournament. If the mean, so there you go, the mean is going to be equal to 71. And then standard deviation of 3.9. Standard deviation of 3.9. What is Josh's z-score, right? So z-score, all I'm going to do is plug it in and then see what we get. So it's the raw score first minus the average, which is 71, over standard deviation. Okay, that's going to be 11 divided by 3.9. Let me just make sure it's 11. Yes, it is. All right, so now calculator time, 11 divided by 3.9. It's going to be equal to, what is that, 2.82. Since it has more numbers, I'm going to go ahead and write them. And then I'm just going to go ahead and focus on the next number after 2, which is a 0. That means it's going to stay as a 2. So 2.82, that's his z-score. And now this is why it becomes just so useful, right? If all you have is just this information there, or basically just think of it like if all you have is this paragraph, you're like, all right, cool, like he obviously scored higher than the average, but now you're basically saying, hey, his z-score is 2.82. That means he significantly scored above the average, okay, because the number is just so big. I know 2 is pretty small, but when you're talking about, think of it, and remember in the standard deviations, we always went like 3 away, in both directions. He's basically like 2 point. He's like over here. So imagine he like this is his time, or his score. So that means he scored like higher than all of these people here, technically, right? I know that's a percentage, but you can multiply by how many people in the tournament and stuff like that. But there you go. That's what it really means. Okay, you really want to think about it. Okay, so let's go ahead with this one. See what you can do. Samantha sold 34 bags, so that's her selling. So she went ahead. That's the X. For fundraiser, if the mean number of bags is 38, standard deviation is 2.5. This is a lot of bags to sell. Find Samantha's z-score. Yeah, this is way too many bags. All right, but whatever. All right, so let's see. Z-score, it's a fraction, blah, 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 standard deviation. But okay, X goes first, the raw score. Standard deviation is 38. Sorry, the mean is 38. Standard deviation is 2.5. 34 minus 38 is -4 over 2.5. Okay, so right there you see that negative sign. Do not lose that negative sign, okay? Keep it there. So it's going to be -4 divided by 2.5. And that's going to give me -1.6. It doesn't give me any more. Let me put a line there, okay? It doesn't give me any more digits, right? The calculator is exactly -1.6. So what I'm going to do is I'm going to go ahead and put that 0 there, okay? You need to do that. Get into the habit of it. It's going to be really important once you get to the table and whatnot. Okay, so there you go, right? That's how you calculate z-scores when you have information. Let's go ahead to the next example and see what's going on. So if Rachel can hold her breath 25 seconds, and the mean time for holding one's breath is 25 seconds, with a standard deviation of 3 seconds, what is her equivalent z-score? So same thing as before, let's just break it down. So Rachel can hold her breath 25 seconds. So that's her basically raw score, if you want to call it whatever. Mean time is 25 seconds as well. Okay, cool. Standard deviation is 3 seconds. What is her equivalent z-score? So the z-score, right? If you notice, the equation is not on here, so I mean you don't have to memorize it, but just have it there written all the time. It's this one right here, okay? I basically haven't memorized because I've been using it throughout this whole time. So the z-score is equal to your score minus the average over standard deviation. Okay, so what we get there is 0 divided by 3, and then some of you guys are going to keep going through this and you're going to be like, wait, I think I made a mistake. What's going on? Well, let's think about, in the previous time in this video, her score is exactly right on top of the average. So the fact that she scored exactly the average means that her z-score is equal to 0. So it just means she's just average when it comes to holding her breath, okay? So let's go on to an example where now you are basically, I'm not gonna lie, it looks hard, but let's slow it down, take your time, pause the video, read the problem, and see what's going on. Okay, so for this problem, right, if you read it, it's basically giving you information about 2 different types of tests. If you don't know how to say this is called the LSAT. It's what think of it like like the SAT and the ACT, but for college students when they're trying to go into law school. And then the MCAT is the same thing, but now you're trying to apply to medical school. Okay, so that's just what those tests are called. So this person called Juwan, I'm gonna assume that's how you say it, right? Juwan took both exams. Let's just say this person is just super like, yes, I want to be a lawyer or a doctor? They did amazing in school or whatever, right? But so they took both exams. He scored 172 on the LSAT and a 37 on the MCAT. So you basically have two different z-scores that you can calculate because it's 2 different tests. And then it says which exam did he do relatively better on. Okay, so what we're doing here is we're going to get 2 different z-scores. Okay, one for the LSAT and then one for the MCAT. And then what we're going to do is just basically compare these two numbers and saying, which one did he relatively do better on, because it's either further away from the from the mean, but obviously it has to be a positive, right? Because that means he did better than the mean. All right, so let's go ahead and let's do that. If you completely forgot, right, this little mu here, I'll draw it right there. It's really bad, but this little mu is like an M, sort of in a, what is that, like cursive. This one stands for the average, okay, and then this other Greek letter, I believe it's called sigma. I'm not gonna lie, I don't remember, but whatever. It stands for the standard deviation. So let's go ahead and let me just try to organize myself. So the LSAT, I'm gonna do it in green. So let's see. He scored a 172 on the LSAT, so this is his score. So 172 minus, we know the equation then says subtract the average, which the average is 151, and then divide that by standard deviation, which is 10. Okay, so that'll be for the LSAT. And then let's go ahead and let's do for the MCAT. Let's see. He scored a 37 on the MCAT. Then the average was 25.1, and then the standard deviation is 6.4. What I'm going to go ahead and do now is just, grab my calculator and calculate these two z-scores, and just basically just see which one is greater, right? In a positive direction, of course, because then that means that he scored relatively better on that one when you compare it to the average, of course, and consider standard deviation. So let's see, 172 minus 151 is equal to, let me keep that in green, is equal to 21 divided by 10, which is equal to 2.1. Okay. Remember, we need 2, so I'm going to add 2 decimal places, so I'm going to add a 0 there. And then let's go ahead and do the next one. 37 minus 25.1, it equals to 11.9 divided by 6.4. Okay, so all of this is calculated, okay? Divided by 6.4, which is equal to 1.859. Since we want 2 decimal places over, that means the 5 is either going to change or stay with the number next to it, which is a 9. So that means it's going to actually go to 1.86. Okay, so that right there. So this person named Juan has 2 z-scores, right? We can obviously tell which one is bigger, but if you can't, I'm just going to go ahead and do it over here. So his z-score for the LSAT is going to be equal to 2.10, and then the z-score for the MCAT is going to be equal to 1.86. So obviously for both of them, he scored better than the average. But the one that really stands out would be the one that is considered to be the LSAT, because of the fact that it's 2 standard deviations above it, which is pretty high. Okay, so what this potentially could mean is just that maybe this person should be applying more to law school, I guess, than med school, but this is still a pretty good MCAT score from what I know. But there you go. So that's how you can compare z-scores. That's a little bit more information. What I see a lot of people doing this for is, or like, people your age for juniors, seniors, is instead of comparing, LSAT, MCAT, you can compare SAT versus, so let me write that down. So you can compare, for some of you guys that want it, right? You compare SAT versus ACT, and you can see which z-score is higher, and that obviously means you scored better in that one than relative to your peers. So that's the one that you would want to send to the colleges when you guys apply and whatnot. So there you go. That's how z-scores work. Okay.